Hi everyone, Sir Jules here, and for today's video we'll be talking about what is chemistry and what are its 5 main branches of chemistry. So, to first define what is chemistry, it is the field of science that studies matter, what is it, and how it changes through different chemical reactions. So as you can see, chemistry involves different chemical reactions, and these reactions lead to another byproduct because of the reaction that they have with their atoms that creates the reaction and the result itself. Now, since chemistry is the study of matter, and by definition matter is everything that occupies space and has mass, so everything that we see, we hear, we smell, everything that surrounds us is involved with chemistry since they have both volume, they occupy space, and it has mass. So that's chemistry. Chemistry is all around us. Now we're going forward with what are the 5 main branches of chemistry. Now the first main branch of chemistry, you guessed it right, we are chemistry, we are under the organic chemistry. So what is organic chemistry as a first main branch of chemistry? So this is the chemistry wherein it involves all carbon-containing compounds. Example, we humans, we are mostly composed of carbon compounds, that's why we're called organic, and we decompose throughout time because we are organic compounds, composed of organic matter, because we are living things, and we are mostly components of carbon compounds. So that's organic chemistry, as long as it contains a carbon, because as you know everyone, carbon is the most friendliest element in the periodic table, because it can bond up onto how many millions of possible products based from carbon to carbon reaction only itself. So that's why we have a specific subject just for that organic chemistry, carbon-containing compounds. Now, but not every compound is under organic chemistry, it contains carbon except from carbon dioxide and carbonate, so those two are the exceptions as an addition for the organic chemistry. Now if we have the organic chemistry, we also have its counterpart, the inorganic chemistry. So what is inorganic chemistry? So if we'll take a look at the periodic table, all those 118 elements, carbon is one of them. So if carbon itself has the field of chemistry, branch of chemistry as organic chemistry, then the rest of the periodic table of elements is covered in inorganic chemistry. So basically it's just those compounds that don't contain carbon. And that's why if you've been through an inorganic class, they discuss mostly about the periodic table for the whole term. For the whole semester, it's all about the periodic table, all about the elements, what are its structures, what its atom looks like, so those kinds of stuff, and especially its properties. Now, since we have now the first one, organic chemistry, second one, inorganic chemistry, and the third one, we're going to the biochemistry. So what is biochemistry? So biochemistry, the name itself, biology and chemistry, so that is the derivation of its terms. So from the name itself, it's the link between chemistry and biology. So just for example, we humans, we are composed of organic matters, and the processes within us, the chemical processes, the chemistry processes, gives life to us as to why do we breathe, why we can see, why do we salivate, all those kind of qualities and properties that we do as humans can be explained by biochemistry. So how does the specific chemical reactions of the elements and compounds that is within our body doing its part in order to keep us alive in our day-to-day processes? So that's biochemistry, the chemistry behind biology, so that's how you can simplify it. Now the fourth one, we have physical chemistry. So if we have biochemistry as a link between biology and chemistry, then we also have physical chemistry, so that's a link between physics and chemistry. So the inclusion for this branch of chemistry is that how can we use chemistry into physical applications? So just for example, we have lightsabers, so we have specific chemical reactions to make a lightsaber, the one from Star Wars, right, to make it a sharp blade, but composed only of light or photons. So some kind of those concepts, lasers, so those kind of things, they're under the physical chemistry. And for the last main branch of chemistry, you guessed it right, it's nuclear chemistry. So if anyone remembers the atomic bomb that was dropped at Nagasaki and Hiroshima during World War II, that's an example of nuclear chemistry. So nuclear energy is a great source of energy to be released through different chemical reactions. It's a series of chemical nuclear reactions. So it's a study of the atom, how it produces that immense amount of energy during that short amount of time. So it's basically taking a closer look at the atom and why do you have this nuclear energy? Just because of the simple nuclear of the atom. So that's nuclear chemistry. Now thank you so much for watching this video, and I hope you learned something from what I've discussed for today, and I'll see you for the next one. Have a great day. Bye-bye.